Hi everybody, welcome back. So in this video we're going to talk about functions and coordinate plane. And if you are hearing coordinate plane for the first time, it's going to be amazing, because I'm going to tell you a story about how coordinate was found, right? The way we have learned number was more like a number line something, right? And whatever the math we have learned till fractional decimal, it was doing okay enough job to do some operation, but we wanted to advance in maths, and so people at that time, right, came up with a coordinate system which helped us to visualize math more easier, and locate the place and these all kind of thing, right? So the guy who did that was Rene Descartes. So we'll start with this video. So today we're going to talk about function and coordinate plane, and let's start with a problem. Let's say I have a $1, and if I convert in euros, it will become 5. If I have 2, it will become 7, it will be 3, 9, 4, 11, 5, 13, 6, 15. So what will be the amount I will get for $7, right? So you can see the data, you can see some pattern, and maybe you can answer these things, 7 things. But I want to tell you exact solution. Like this time, these numbers were easier number. Maybe there was a number which it's very hard to see the pattern, and you might not able to find the answer. For this one, even some of you might not able to find the answer. So we will find a systematic way of doing things where we can have any kind of problem, and we can use this function and coordinate plane to find out the answers, right? So we'll get going. And so Rene, one day he was on the, what do you say, he was looking on the ceiling, and while talking to a friend, think like he was talking, imagine there was a scenario where he was talking to his friend who is out the window somewhere in the other house, and they can speak, right? I don't know if there was a telephone back then, but think like he was talking and he was telling, hey, I have a fly on my ceiling. The other friend said, where is the fly? So he tends to go and describe that. So he describes something like he sees the ceiling, and ceiling has this lines over there on top, like already some horizontal lines, and he know that okay, I could tell one line, but I cannot tell the exact location of the fly. So what he did, he draws some imaginary lines on his wall, imaginary, like he saw himself, he visualized it, okay, there were some lines, and those lines were something like this, and then he made coordinates like this. He called it x-axis over here, and the x-axis you can see, this was you can see there was 0 over here, 1 2 3 4, and then we have other number systems, like on the y-axis we have 0 1 2 3, and we can totally tell what number over here it will be, right? So we can tell that okay, this fly could be at 2 comma 2, right? So we can have their coordinates. So this thing I could tell it to my friend who is in the other side, on the other house or something. I could from here shout, hey, the fly is on the 2 comma 2, and then he said, what the fuck is 2 comma 2, right? So then he will say, hey, just draw imaginary lines, make them, you have this separation of these lines between this distance approx, and then you will know the location of the fly. So this actually helped us to visualize the location of fly. Even if you're reading, let's say I have to write a paper, and somewhere if I have to write it in a letter and tell it to somebody else, he can also know, okay, he was talking about fly which was on somewhere. This was a simple use case, but there are so many other problems where the knowing the position is very important, right? So even when the fly change his location, he will come to new location, so you can probably find new location. It will be 1.5 comma 2.5. So there is a mistake over here, it should be 2.5. So 1.5 comma 2.5 should be the answer. So this way. So this way we learned about coordinate system, right? We can draw vertical lines, horizontal line, like a grid system, and then you can have these numbers, and you can use it for the location. He was very lazy, he couldn't remember where all the stuff in the house, so he actually started marking on the floor as well, and he started keeping things, one on the book, the boots are on somewhere like this, and then he made a list, okay, boots 3 comma 2,9, star book 4,5, cactus 3,8, hat 6,7. Like this, he plotted whole his house and kept look things. And whenever he wanted to find something, he will go in the list and see where in which coordinate it has been written. So for him, it actually worked for him. So if you remember, I gave in you a problem of dollar and euro, right? Before solving that problem, I think that is a intermediate level problem. So before that, we're going to solve some easy problem, which will basically get you thinking to how to solve that problem. So if you see over here, if you give me $1, I'll give you 2 candies. If you give me 2, I'll give you 3. If you 6, I'll give you 7. If you give 9, I'll give you 10. So how many candies I'll give for $4 and $8? So you can probably now you can tell that maybe 9 or something like this, right? But there is a systematic way, which I'm repeating again. There is a systematic way to do things. So we're gonna follow that, and so it goes something like this. We will use Rene Descartes method, right? Where I'll draw these axes as dollars. So the horizontal lines with these numbers, so that I can locate those values, right? This time it is not simple placing things, but I could locate it. So dollars, I'll say 1, 2, 3, 4, 5 on the horizontal axis and candies on the y-axis. So if you remember from the last example, so this means 1, 2. $1 equal to candies. This will means 2, 3, something like this, right? So over here 1, 2, I plotted 2, 3, 6, 7, 9, 8, right? This way I can plot those information on a coordinate system, and I can draw a line matching those points, and that becomes a function, right? If you have seen our previous videos where we have talked about functions, right? Functions are something which we'll discuss probably in later part as well, but I'm telling you over here as well, function is something which you give you input and you get some output, right? So this line becomes a function. We'll probably solve this thing, but let's go learn about function a bit more, right? So functions are, as I told you, you pass some input, you get some output, and blender is one of the example. You can pass tomato input, and you get puree out of it, right? So that will be one of the example of the function. Money converter, the first example which I gave you, like conversion of the money, it could be a function. You give $1 and then you get the currency exchange, whatever, right? So this way, this is a function, right? And there is a algebraic way of representing function, which you have learned in the previous video, math as a language, where I've described there are operators, there are functions, how we input things and these all things, right? Same way for the previous example, we had our coordinates like this, and we draw this line. This line is a function, and how we can input something is basically pass a value from here and get the value out of here. So I pass the value 4 over here, which is basically doing a straight line over there and then seeing what is the opposite from this point in a straight line manner only. So we'll see 5. This function is basically candy function, knowing the candy function to know how much candies I get, and I pass the input 4, I'll get the value 5 over here. And if I do it for this one as well, over here I'll pass $8, which goes like this to the function, and the output comes like this, 9. So this is a function, and using this function I can find the solution, $4, $8, whatever. And we can also write it in algebraic way, as we know that the answer was coming 1 extra, right? So we can write in algebraic from x plus 1, right? You can see the pattern, and we can write over here. We just tend to find the pattern, which was very easy in this example because it was only extra 1 more. So whatever the input x I'll give, I'll add 1 and pass on. So 8 I'll pass on 8, 1 plus 1 9, which we also got through graphical method as well. 4 plus 1 plus 5, that also I got from graphical method as well. So this way, but there is a systematic way to find the equation as well. You don't have to guess or see the pattern or something like this, which we're going to see forward. Now there is another example before solving our money problem, dollar and euro conversion. We have this toothpaste promotion where if you buy 1 toothpaste, you will get 2 toothbrushes. If you buy 4 toothpaste, you will get 8 toothbrushes. If you buy 7 toothpaste, you will get 14 toothbrushes for free. So for how many toothbrushes I will get if I by 2 and 6 toothpaste, right? So we can again think it as a coordinate 1 comma 2, 4 comma 8, 7 comma 8, and one of the line I'll make a horizontal line make as a toothpaste, and vertical line I will make toothbrushes, right? And that will also work for us. So there I did a mistake. Actually, toothpaste should be over here and toothbrushes should be over this side. So you can just interchange this. Toothbrush should be over here. And what I meant was now you can plot these dots over here and draw a straight line. And once you have the straight line, there's a function, then you can use this too, because we wanted to find this value, right? So you wanted to find how many toothbrushes for 2 and 6, right? So the step is to draw the function, right? This is the function, right? And using this function, we can input 2 values and 6 values and see what is the output, right? So that we can do, seeing the 2 and opposite values 4. And from here you can see 6 values is equal to 12, right? So this way you can find the values through function. And the algebraic part was easier because we can see the pattern already, like whatever we are giving, we are getting double. 2 I was getting 4, 6 I was getting 12. So we can see the pattern over here, and somehow we able to get the algebraic value as well, which was very simple, of x to x. So whatever the input you'll get, multiply by 2. So for 2, 4, which I think this is pretty simple, and I hope you understood that. But there is a right way where you don't have to depend on the patterns or something. We will find exact solution for any kind of pattern, which is even harder to visualize or understand. So we will carry on with that. Another example before solving our main example. So this one will be little trickier, but not so hard even. So a chicken lays egg as follows. In 1 day it lays 3 eggs, in 2 days it lays 5 eggs, in 6 days 13, in 8 days 17. How many eggs will chicken lay in 4 and 7 days, right? So we have to find 4 and 7 days. So basically we'll create a function, either algebraic or graphical, and then we'll input the 4 and 7 and we'll get the answer, right? So first of all, we will draw all the information we have in the coordinates format. 1, 3, 2, 5. So these will be the days, horizontal values. These will be the x. This is my function. And in this function, I wanted to find how many x in 4 days. That will be basically 9. And how many in 7 days. That will be basically 15. Right? And if you are not able to see the pattern over here, pattern is 2x plus 1. Whatever input I give, just double it and then plus 1. So it is a little complicated. And I hope if you're not able to find the pattern, it's totally okay, because you're going to learn a method. You don't have to look patterns and directly can make equations from ourselves, which is the interesting part of this video. So getting 4, this thing, right? So how we're going to learn it? Before doing that, we have to something know about called slope and steepness. Like you must have read about slope. Slope is equal to something called equation of a line, straight line, y is equal to mx plus c. Right? This function is basically so the egg information, right? Days and x, right? We plotted. This is the function, and somehow our function is a straight line, and there is a algebraic equation for a straight line, right? All the straight line can be represented through this common function called y is equal to mx plus c, right? This is a common formula for representing a straight line, right? If you heard about what is y, what is mx, what is plus c, that we will understand right now. Right? If you have just wrote it or somehow memorized it and you're just using it but didn't understood back then, this is time where we solve it. So we have to know something about slope. How steep or slope this line has. Steepness is basically, this is too steep. Like if I have to climb, think like you have to climb on this thing, ladder kind of thing, right? It's a steep climb, you have to climb over. You'll find it hard. But I've increased the inclination more, like this, it will become steep. So the steepness value, it should definitely represented by a bigger number. The steepness is like this. And when it is like this little steep, that time it should always represented by a very small number, right? And if it is straight, then it's 0, no steepness, like you are free to walk, no, like you can easily walk it. But if there is steepness, you have to put a lot of effort and something like that. We call it slope, we call it steepness. How we can find this number? We know that this is the highest steepest, like this will be the very hard to climb. So this should represent by higher number, and this is lowest. So how we can know exactly? So the way to find is, we need to find a fraction, right? the way we have learned fraction. And then that fraction will be basically take any 2 points in that straight line. It doesn't has to be these points only. You can take this point over here and this point over here. Anywhere. Doesn't has to be these yellow points only. Any point, small point you can take. And 2, 5 and find the horizontal distance like this. We call it a run. Like how much you're gonna run like this, right? Simple. So that value is like over here 6. 6, you can say 6 is represented by here and 2. So this length will be 6 minus 2, 4, right? That we can write over here. And then we have this rise distance, like how up I went, right? So that will be basically this point, which is 13 minus 5 over here, right? This blue line opposite, if I have to draw over here, it will be 13 minus 5. So that will become 8. And that if you put in fraction, that will basically tell me steepness, right? So rise over run 8 upon 4. So that is the steepness for us. And if I solve it, I'll get 2, right? So that is steepness. So this is too steep. If the steepness goes more, it becomes higher number, 3, 4, something like this. If it goes little 1, it will go 1 or something like this, right? And you can find this thing in lot of books or somewhere. You will find the value of steepness will be, they will not tell you, hey, you have to look on the coordinate system, right? Just subtract. So a lot of the time in our math class, we are taught shortcuts first, then somebody explains or not even explain the real value. Right? People will only teachers will come with shortcuts only. They will teach you how to do shortcut, but they will never make you understand how actually visualize and how to. So they'll tell you basically, I'm gonna find 2 points, subtract y2 minus y1, x2 minus x1. They basically, this is finding a rise over run, but just with these not drawing coordinate system, just finding these values 6, 3, 3 minus 5, I'll get 8, 6 minus 2, 8, 4. Right? So I need 2 points. Let's say if we take this point as well, the rise is basically 2 distance, 5 minus 3, run is 1 by 2 over here, 2 minus 1, and again 2 upon 1 will be again. And for this one, we can see the pattern and draw the values like how we got 2x plus 1, right? We can see pattern. If you see pattern, if you're not able to see pattern, that is also alright, because maybe that is in the next slide. Yeah. So we can see the pattern like this, and there is a way which I told you, yx plus c, right? So the steepness becomes this part, the value before x, which we'll see soon. So whatever the slope we found 2, we can paste it over here, right? And before the x value. So this is the x is the input, and in previous example, we somehow able to find patterns and then we got the value. Over here, you just have to pass this steepness value to over here x and see where this line is intercepting on y-axis. This is y-axis and it is intercepting at 1. So that 1 will be added. So this way we'll find this algebraic function. Right? This was graphical. Using graphical only we can find the algebraic function. Right? So you have to first find the steepness, slope of that value, and if you're able to find intercept where it was intercepting, that value if you can write, and that becomes algebraic function for this one, right? And that we can do with same. So now if you have understood, right, how we can get that steepness, and we can also find the values while passing it. If you remember the toothpaste and toothbrush example, in that way also we'll draw a line, we'll see what is the steepness for this value. So let's say if I find steepness over here, rise over and 6 upon 3, basically that becomes 2. You can pause the video if you're thinking it's very fast. And as we know that, okay, steepness slope is 2 over here, right? So I can write 2x, and what is intercepting at 0 point, right? What that means, like whenever you have 0, all the lines, the straight line joining those your coordinate points, 0 means basically they've always passed through 0. It will be always like rotating, but if you have some value, it's gonna go up and down, right? If I have intercept as 1, it will be over here, 2 over here, 3 over here, 4 over here, but this angle will be always there. So what 0 means, basically it is passing from the center, so no values, right? So, and we already know slope is 2, we can write 2x plus 0. You can avoid writing plus 0 over here, right? That will also work. And now we got this value not by saying that, okay, the input and output was double because the slope was 2 as well over here, right? So this way we know that this function is 2x. We can do it with the previous example as well, candies and dollar. So those points were like this, and then we draw a graphical function over here joining this line. You can see intercept is 1 over here, and we'll find the slope. The rise over run is 4 actually over in this case. 4 by 4 is 1, and it'll become x plus 1. Right? X is over here the slope is 1, right? If I have to, even if you don't write 1, it's okay. And this plus 1 is 1. So this way we got this function, not by looking the pattern. Like you can see the guesses, but there will be scenarios where you cannot guess the pattern, and then you have to use this method to find the steepness of this line. And then probably this one is the last example, dollar or candy. Sorry, the dollar and euro, which I asked you initially, right? This one basically, this example, yeah, this one, dollars in euro, we have 1, 5, 2, 7, 3, 9, 4, 11. This again I'll change into points, and then we have to find for 7. So we can find a graphical function, and then we can find a algebraic function, and then we can use both, either of them, to find the answer. We'll plot these points like this, draw a straight line, and then we have to find for 7 euro. If I draw a straight line, I can see intercept is 3 over here, and the value we wanted for $7, you can use the graphical function to find 17, right? And if I have to make algebraic function, I'll use slope and intercept value. So slope is basically 2 upon 1, 2 in this case as well. So 2x plus 3, right? And you can pass 7 into this, 7 into 14 plus 3 becomes 17. So this way we can use both of the functions way, right? On this line as well as the algebraic function to find it. What is the key takeaway from this video is, whenever you have to get the function of this kind of thing, right? So you can get the slope intercept, and this is straight line. Whenever you have to find the equation of a straight line or a function for the straight line, this is the way to go, right? And if you look at, this is also like machine learning, right? Machine learning, if you have any idea about it, we have some previous historical data, and then we can predict the future, right? So we already know some pattern, right? And we made a model. This, you can say, it's a kind of small model. And then we are able to predict the trajectory, what will be the 7 or whatever the new number it comes, I can again get those values, or in the middle anywhere. So learning from the previous example, we can say the future, right? That's a machine learning model basically. It is not exactly like this. You will still win, but this is a very, what they say, academic problem, right? It is over here the lines are properly joining, right? But in the real world, these lines will be not joining. Somehow you will have to find a line which is almost touching by everyone. Not exactly joining, because you cannot find that one. So you have to basically see where this line can be drawn, and then you have the model, and then use it as a AI model or something like this, right? That is the goal for our previous. The next 2 videos will be on that topic, how we can use this information and use it in the modeling. And I hope you understand functional coordinates. It's very useful to not only solving this kind of problem, but to plot and to understand where the location and this kind of thing is, right? It kind of helps us to visualize how math is going, right? So this was it. I hope you liked it. If you have any opinion or any problem, you can ask in the comment section. Do share this video if you feel like your friend or something who is going through hard time, and by this thing they could really get a good understanding. I learned it really late. In my school, I was not taught like this. I was given formula shortcuts, right? From here now you can get a lot of shortcuts. Like if I have to bind slope, I will say y2 minus y1 and x2 minus x1. Whatever the number becomes, that becomes m, right? That way you can formulate this, like create a lot of shortcuts from this whole teaching. And they will teach you shortcuts, and I never got to learn to visualize this way. And I never understood it, but somehow I learned it late. I hope you guys don't do that mistake, what I did, and you can save a lot of time on this. So I hope to enjoy. I hope you're enjoying this one, and see you in the next one.